How about the different technologies for a magnetic sensor, magnetic position sensor, magnetic
Mm.
encoder?
So the standard today, or I should say what has been the standard is Hall. And the reason for that is that it can be, you can use a standard silicon process. So no special fabs, no special anything. Hall has a decent amount of white noise. So we're probably going to max out around 14 bits. You could get more, but at the expense of so-called dynamic bandwidth. In other words, you can keep filtering that white noise forever and ever and ever. So if you're rotating really, really slowly, you can get more. But let's say for a real world application, you're going to max out around 14 bits. To supplement that, the MR technologies, the magnetoresistive technologies, have been, let's say, growing in popularity. We have some competitors that use GMR, giant magnetoresistive. MPS has settled on TMR, tunneling magnetoresistive. And so our latest part uses a TMR. And that one today, for the same bandwidth that you would get out of our Hall, you get 3 extra bits out of our TMR part. And we think that we can extend that. We think that we'll be able to get it to 5 to maybe even 6 more, 5 to 6 bits over Hall. So another 2 to 3 bits beyond what we have in our current generation part. And then we'll start to hit the limits of that technology. That's, like I mentioned, 17, maybe 18 bits is really pushing the edge to the point where you just we'll then have to, that's where the fun starts. We get to think of kind of brand new technologies to keep extending and keep, we're trying to extend our reach as much as possible into the standard encoder field. And who knows, maybe someday we'll get to 20 plus bits
Of actual data.
Of actual 20 plus actual bits. So based on the noise, so that you can, we can talk about that later too.
Can you go just like a quick overview of because there's TMR, GMR, AMR as far as magnetoresistive technology. Do you want to just give the quick what the differences are?
Well, I'm not an expert on the magnetoresistive much. TMR I know quite well now because of our product. The biggest difference is the noise profiles of them and the sensitivities. So the reason that we like TMR over I would say the most ubiquitous is GMR. I don't see a lot of AMR, which I don't even know if I can remember. It's amorphous. I don't remember what the A stands for in AMR. But anyways, so we see a lot of GMR out there. We decided on TMR, and the reason is it's very, very sensitive. It can handle a relatively high magnetic field range, dynamic range, so we can get down to single digit milliteslas, maybe 4 or 5 millitesla, and up to 100 plus millitesla. And the noise profile is quite nice. It's a so-called pink noise, 1/f noise. So it's well known and well characterized, and it works quite well for our spin axis. Going back to our basic technology, the way that we do our angle sensing is a little bit different than many of our competitors with the so-called spin axis. I wrote an article about it. You can find it. I think it was in Bodo's Power Magazine, which now got bought, but it's out there. Search for Ted Smith and spin axis. And the TMR works really, really well. It fits nicely into our spin axis technology, our time to digital conversion.